Let's just look at some more trig equations. We need some extra practice. So we're going to be asked to solve the following equations for the given interval, and of course always give exact values when you can. Meaning if they're in that unit circle that you're supposed to have memorized, then those are the kind of values I want. If not, let's do decimals and let's give 3 decimal places. Alright, so number 1, we're given the interval for x to be 0 to 3. But if I look at my angle, and that's what that is, the sine of that angle, it is not just x, it's pi over 3 times x. So I have to adjust my interval by multiplying both of these by pi over 3. So that's my adjusted interval. But let's proceed. What do we need to do? We need to isolate that trig function first. So let's divide both sides by 2 pi. So I have the sine of pi over 3x equals to 1/2. At this point you should say, 1/2, sine equals 1/2. I know that. Alright, so you could just answer it at this point, but really algebraically what we are doing is we're taking the inverse sine of both sides of this equation. And the inverse sine and sine, they are inverse functions, so they cancel each other out or undo each other. But at this point we are asked what angle gives us a ratio of 1/2 in this interval. Let's say that again. What angle gives us a ratio, a sine ratio of 1/2 in the given interval for between 0 and pi, which means quadrant 1 and quadrant 2. Since the sign is positive in both of those quadrants, I should know both of those answers. So for the sine is 1/2, you should just know it's pi over 6 in the first quadrant and 5 pi over 6 in the second quadrant. You need to have those memorized. Then the last step we do is to solve for x by multiplying both sides by 3 over pi and reducing those fractions. These answers are in the original interval between 0 and 3 because we've solved for x. Let's look at another problem. Cotangent. Maybe not our favorite, but let's keep going. Okay, so we're given a normal kind of interval between 0 and 2 pi, so I need to look at all 4 quadrants. But do I? Not really, because this is x. I have x over 2, so I need to divide both of those by 2. And again, I am just looking at quadrants 1 and 2. Keep that in mind. Okay, so just like the last problem, I need to isolate my trig function, so subtract 1 on both sides. I have a square, so I need to square root both sides. Don't forget your plus or minus square root of 3. At this point, you might be saying, I'm not very comfortable with cotangent, I'm better with tangent. Okay, then you can take the reciprocal of both sides. So we could say the tangent of x over 2 equals 1 over plus or minus the square root of 3, or if you rationalize it, it looks like that. Is that in your unit circle? Should you know that? Yes, you should. I think about my 30, 60, 90 triangle, and I know that the tangent of theta is defined to be opposite over adjacent, and I look at my angles and I go, well, if I pick 30 degrees, I have 1 over the square root of 3, which is that. So I know that the tangent of 30 degrees is 1 over the square root of 3. I also know that 30 degrees in radians is pi over 6. So lots of things to think about. Right, so again, we're solving for x over 2. So I'm taking the inverse tangent of 1 over plus or minus the square root of 3. And I need to look at this interval, quadrant 1 and quadrant 2. So tangent is positive in quadrant 1, it's negative in quadrant 2, so that means I need two answers because I have a plus and a minus. So x over 2 in quadrant 1, it's pi over 6. In quadrant 2, it's 5 pi over 6. Then I'm going to multiply both sides by 2 to solve for x, and I have pi over 3 and 5 pi over 3, and those two answers are in my original interval. Third problem, this is quadratic. It all has tangents. I don't need an identity. I just need to think quadratic equation. And so I'm going to kind of come over here and make my brain think of, well, what if it was 3x squared minus 5x minus 4? Could I factor that? No, I couldn't. I would have to use the quadratic formula. But if I were using the quadratic formula for that one, I would just say x equals. I don't have x. I have the tangent of theta, or the tangent of x. So I need to say the tangent of theta equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so yes, we're going to need a calculator. So we have 25 plus, I believe that's 48 over 6, 5 plus or minus the square root of 73 over 6. So the tangent of theta is 5 plus the square root of 73 over 6, and tangent of theta is 5 minus the square root of 73 over 6. So now I'm going to get out my calculator. So I'm going to have 5 plus the square root 73, and I'm going to go ahead and hit enter, and then I'm going to divide by 6. It's just a little bit safer that way. So I have the tangent of theta is approximately 2.257. Over here I have tangent of theta 5 minus the square root of 73, and again I'm going to hit enter, divide by 6, and I get negative 0.59, let's see, 07. Is that theta? No, that's just the tangent of theta. Okay, I'm looking at all four quadrants, not changing it, so that means I need to have 4 answers, and they all have to be positive between 0 and 2 pi. Okay, so looking at this one, the tangent is positive in quadrants 1 and 3. The calculator is going to give me an answer in quadrant 1. How am I going to get that answer? I'm going to say the inverse tangent of 2.257. And it's going to tell me 1.154. That's in quadrant 1. How do I get it in quadrant 3? Well, look at it. Here's an angle in quadrant 1. It would be the exact opposite in quadrant 3, so I just need to add pi to it. So I'm going to come over here and say plus pi and get approximately 4.295. So that is quadrants 1 and 3. Okay. Here we're going to take the inverse tangent of negative 0.5907, and the calculator is going to give me negative 0.5335. I cannot have a negative. That's in quadrant 4. Okay, so I'm over here in quadrant 4 as negative 0.5335. How am I going to make it positive? With the same angle, I'm going to add 2 pi to go all the way around the circle. Okay, so theta in quadrant 4 is 5.749. But now I know that it's negative also in quadrant 3. Okay, so I need to go over here. It's a difference of pi. So I'm going to subtract pi from that answer. and get in quadrant 3, we get my answer of 2.608. Now that's not the only way to get those 4 answers. That's just the way my brain is thinking this morning, but you need to know what your calculator gives you and how to get all the other answers. Okay, so again, tangent was positive in quadrant 1. Calculator gave me that answer. I need to go all the way to quadrant 3. This is quadrant 4, negative, but because my interval says it has to be positive, I took this and added 2 pi to get that answer. That's in quadrant 4. And then I had to back it up 180 degrees, which is pi radians, so I'm going to subtract pi and get that answer. Okay, this one looks a little bit less daunting. We have some secants. I got 2 theta. Okay, keep in mind that's going to change my interval because this is theta. So if I want 2 theta, I'm going to have to go around that circle twice. That means I'm probably going to have a lot of answers. Okay, but just like the first 2 problems, I'm going to isolate my trig function. I'm going to take the square root. Don't forget your plus or minus. Make sure that that square root goes all the way over the whole fraction. And at this point, again, kind of like on problem number 2, if you're not feeling comfortable with secant, take the reciprocal of both sides. So that would give me the cosine of 2 theta. And if I flip this one, this is going to be plus or minus the square root of 3/5. So 2 theta is the inverse cosine of plus or minus the square root of 3/5. This is where we have to look here. I'm in cosine land with plus and minus. Well, that covers all 4 quadrants. So I've got quadrant 1, quadrant 2, quadrant 3, quadrant 4, and then I have to do it again. So I'm going to have 8 answers. And 3/5 is, square root of 3/5 is not in my unit circle. So again, I'm going to have to go to my calculator. Alright, so I want the inverse cosine of the square root of 3 divided by 5. So I get 0.6847. Now cosine's positive in quadrant 1. Alright, so my calculator gives it to me in quadrant 1. How am I going to get it in quadrant 4 as a positive answer? Well, as a negative answer, it's 0.6847 because I'm going just in the opposite direction. So I could add 2 pi to that to go all the way around. Lots of different ways. So here's quadrant 1. I want quadrant 4, so I'm going to say 2 pi minus my answer. 2 pi minus 0.6847. And I'm going to get 5.598. Okay, I'm going to take care of the other answers here in just a minute. Okay, so now I want the inverse cosine of negative. Okay, so I just did positive, so I know cosine's negative in quadrants 2 and 3. So I'm going to take the inverse cosine of negative. The calculator is going to give me 2.457. That's in quadrant 2. Ooh, how do I get that answer in quadrant 3? That's a little bit tougher. Okay, so let's just kind of look. So this is an angle of 2.457. I really need to know what my reference angle is. So if I say pi minus 2.457, that's going to give me this angle. That's my reference angle of 0.6847. That's the same as this angle down here. Does that look familiar? It should. Okay, so how am I going to get my answer? So this is in quadrant 2. How am I going to get my answer in quadrant 3? I'm going to take pi and add it to my reference angle and get 3.826. But how many answers do I have? 1, 2, 3, 4. Now remember, and I made a mistake. Those all should be 2 thetas. 2 thetas, 2 thetas. That's just once around the block. Okay, how am I going to get 8 answers? I'm going to take all 4 of these and add 2 pi to every one of them. Okay, because it's just going to go around the circle again. Okay, so then I'm going to have 8 answers, and that is equal to all 8 answers. Okay, and that's 2 theta. But I need to solve for theta, so I would then take all those 8 answers and divide them all by 2. I'll let you finish that. So here's one more, similar to the last one. So we have cosine squared. And again, we have x, but our angle is pi over 2x. So I need to multiply both of these by pi over 2. So I'm going to have 0 to 2 pi. That looks normal. Again, we're going to isolate. So we're going to divide both sides by 4. And I have cosine squared of pi over 2x equals 1/2. I'm like, 1/2, I know that. But darn, I have a squared. So I've got to take the square root of both sides. And I have cosine pi over 2x equals plus or minus 1 over the square root of 2, or rationalize square root of 2 over 2. Well, that looks kind of familiar too in my unit circle. Again, if I look at my triangle of 45 degrees, I believe the cosine of 45 degrees is adjacent over hypotenuse, and 45 degrees is pi over 4. So I think I should have an exact value here. So pi over 2x equals the inverse cosine of plus or minus 1 over the square root of 2, and I have to look at this interval. That's all the way around the circle. That means I need to have 4 answers because I have plus or minus. So I have pi over 2x. I know I need pi over 4, 5 pi over 4, I skipped 3 pi over 4, and 7 pi over 4. Then I'm going to multiply everything by 2 over pi. And so I get x is equal to 1/2, 5/2, 3/2, and 7/2. And if you go back and look at your original interval, all of those answers are between 0 and 4.